Intensive practice 3.2. So questions number 1. Solve the following simultaneous equations. So we have one linear and one non-linear equations here. So first, let us label it as equations 1 and 2. So I'm going to solve this using the substitution method. And I'm going to choose the y from the equations 1 to be the subject of the formula, which later on we're going to substitute into the y in the equations number 2. So this is easier for me because I only need to substitute once and expand once only if I use the y as the subject of the formula. So from equations 1, we're going to move this negative 3y to the other side so that it will become a positive 1. Therefore, y is equal to x plus 4 divided by 3. So I'm going to label this as equations number 3. So now let us substitute this equations number 3 into the equations number 2. So next I'm going to expand for this part. Now, I want to get rid of the denominator number 3 there. So I'm going to multiply each terms by number 3. Alright, so what happened next is here you're going to have 3x squared. This number 3 here will be cancelled. Therefore, you're going to get x squared plus 4x here minus 120 equal to 0. Next, I'm going to solve for the like terms. So here 3x plus x squared, I'm going to have 4x squared. Now for these quadratic equations, I can simplify it by dividing every terms using number 4. So you're going to get x squared plus x minus 30 equal to 0. And for these quadratic equations, you are able to factorize it completely. You can always check this by using your calculator. So when you do the factorization, so the first bracket is x plus 6 and the other bracket is x minus 5. Therefore, x is equal to negative 6 or x is equal to 5. So now we're going to find the value of y. So here we are going to substitute the value of x that we find into the equations number 3, as the y already become the subject of the formula. So y equal to negative 6 plus 4 divided by 3. That is the first one. So the other one will be 5 plus 4 divided by 3. So here when you solve it, you're going to get negative 2 over 3. And for the other y, it's going to be 9 divided by 3, which is equal to 3. So we have finds the value of x, y for these simultaneous equations. So the first pair of answer will be when x is equal to negative 6, the y is equal to negative 2 over 3. And another pair is when x is equal to 5, y is equal to 3. Questions B. So this is still the simultaneous equations involving one linear and one non-linear. So first, let us just label as equations 1 and 2. So we can solve this. It's easier using the substitution method. So I'm just going to choose the k from the equations 1 to become the subject of the formula, which later on we're going to substitute into the k in the equations number 2. So from equations 1, k is equal to 3p minus 1. So this is the equations number 3. So now we're going to substitute the equations 3 into the equations number 2. So the k, we just replace it with 3p minus 1 So next I'm going to expand this. So here you're going to have negative 6p plus 2. So this is a quadratic equation, so I'm going to arrange this and solve for the like terms. So first 3p squared, and when this p minus this p, it will be cancelled. So later on we just left with negative 6p here plus 2 equal to 0. Alright, and for this quadratic equations, if you check this using your calculator, you won't able to factorize it completely as involving decimals. So we can find the value of p here using the formula. So in general, the formula is x equal to negative b plus minus square root of b squared minus 4ac over 2a. So now, if we compare these quadratic equations to the general forms, you will find that here the value of a is equal to 3, the value of b is equal to negative 6, and the value of c is equal to 2. So here, to find the value of p, it will become p equal to negative of negative 6 plus minus square root negative 6 square minus 4 times 3 times 2 and divide by 2 times 3. Alright, so here if we simplify this, you're going to find that this is going to be positive 6 plus minus the square root of 12 divided by 6. So we're going to have two values of p. One is 6 plus square root of 12 divided by 6. Another one will be 6 minus square root 12 divided by 6. So solve this using your calculator. You'll find that one of the value p is 1.5774, or the other value p will be 0.4226. So always give your answer at least up to 4 significant figure. So now next we're going to find the value of k. So I'm going to substitute here the value p, which we already find. So just substitute it into the equations number 3. So here if we solve this, you're going to find that the k is equal to 3.7322. Or another value of k will be, solve this, you want to get 0.2678. So now we already solved for this question. So we have two pairs of answer as usual. So the first value is when the p is equal to 1.5774. The value of k is equal to 3.7322. And another pair of answer is when p is equal to 0.4226. The k is equal to 0.2678. Questions number 2. Find the coordinates of the point of intersections of the curve x over y minus 2y over x equal to 1 and straight lines 2x plus y equal to 3. So the point of intersections. So when we solve the simultaneous equations, the value of x and y that you find, that is the point of intersections. Alright, so first, I'm going to write down the equations here. So first, I'm going to label these as my equations 1 and my equations number 2. So we're going to solve this using the substitution method. So I'm going to choose the y from the equations number 2, which later on I'm going to substitute it into the equations number 1. So from equations 2, y is equal to 3 minus 2x. So this we're going to label this as the equations number 3. So now I'm going to substitute the equations 3 into the equations number 1. So you're going to get x over 3 minus 2x minus 2 times 3 minus 2x over x equal to 1. So the first thing I'm going to do, I'm just going to expand for this part. All right, so you're going to get, so 6 minus 4x over x equal to 1. So now I'm going to combine these two fractions as one. So I need to equalize the denominator first. So for the first fractions here, I'm going to multiply it with x. And for my second fractions here, I'm going to multiply it with 3 times 2x. Alright, so here you're going to get x squared minus, so here you're going to have 6 minus 4x multiply 3 times 2x. And for the denominator, so you're going to have 3x minus 2x squared equal to 1. Alright, so now I'm going to expand for this part. And later on, I'm going to move this denominator 3x minus 2x squared to the other side. So next, I'm going to have x squared minus, so I'm going to put a bracket here. So if I expand this, 6 times 3 is 18. And then you're going to get negative 12x minus 12x again plus with the x squared. So equal to, so when 1 multiplied by 3x minus 2x squared is still going to be the same. Alright, so next I'm going to get this thing out of the bracket, and later on I'm going to move this to the left hand side. So here you're going to have a plus 12x Alright, so we're going to solve for the like terms and arrange these equations. So first, let's solve for the x squared. So x squared minus 8x squared plus 2x squared. So here you're going to have negative 5x squared. So next, so when this 12x plus 12x minus this 3x, you're going to get a plus 21x minus 18 equal to 0. So now if you look at these quadratic equations, the a, which is the negative 5, so normally we want to have a positive one, so it will be easier for you to do the factorization. So but I would divide each of the terms in the quadratic equations here by negative 1. When you do that, this negative 5 will become a positive 5, and this plus 21x will become negative 21x, and this will become a plus 18 equal to 0. So now check this using a calculator. You are able to factorize this completely. So the first bracket that you're going to have is 5x minus 6. The other one is x minus 3 equal to 0. Therefore, x is equal to 6 over 5, or x is equal to 3. So now we're going to find the value of y. So we're going to substitute the x that we find into the equations number 3. So the first one is y equal to 3 minus 2 times 6 over 5. Solve this, you're going to get 3 over 5. All right. Or the other one will be 3 minus 2 times 3. So here will be 3 minus 6, which is equal to negative 3. So now we want to find the coordinates. So the first coordinate is when the x is equal to 6 over 5, the y is equal to 3 over 5. So that is the first coordinates of the intersections point. And the other one will be when the x is equal to 3, the y is equal to negative 3. Questions number 3. Given that the coordinate negative 2, 2 is the solutions to the following simultaneous equations, so finds the value of h and of k. Hence, finds another solutions. So these coordinates is actually the intersection point between these two equations when you plot these two equations into graph in the Chartesian plane. So this negative 2 and 2 is the points that lies on these two graph. So when you substitute these coordinates back into these two equations, what happens is that the value on the left hand side will equal to the value of the right hand side. So now to find the value of h and k, so I'm just going to substitute these coordinates back into the equation itself. So for the first equations here, which is x plus 1 over 2 y equal to h over 2. So the x here are going to substitute it with negative 2, and the y are going to substitute it with number 2. Alright, so here will be cancelled. Negative 2 plus 1 is negative 1 equal to h over 2. So we're going to move these 2 to the other sides. Therefore, h is equal to negative 1 times 2, which is equal to negative 2. Alright, to find the value of k, so this 1 over x will become 1 over negative 2 plus 2 divided by 2 equal to k. So this is the same as negative 1 over 2 plus 1. Therefore, k is equal to 1 over 2. Right, so now we want to find another solution, which is another intersection point. Alright, so we need to solve this simultaneous equations. So now we already know what is the value of h and k. So the first equations, x plus 1 over 2y equal to, now we're going to, so it's going to be h over 2, right? So now we're going to substitute this h with negative 2. So negative 2 divided by 2, you're going to get negative 1. Alright, so this is the first equations. And for the second equation is 1 over x plus 2 over y equal to k, which is 1 over 2. So this will be my equations number 2. Now, if you look at these two equations, both of the equations, they have fractions inside that. So you were able to solve this easier if you don't have fractions. So here I'm just going to get rid of the fractions. So for equations number 1, I'm going to multiply each term by number 2. Alright. So when I do this number 2 here will be cancelled. So the first equations now will become 2x plus y equal to negative 2. And I'm going to let the y to become the subject of the formula. Therefore, y is equal to negative 2 minus 2x. So this will be my equations number 3. Alright, so for equations number 2, in order to get rid of the fractions, which here you have y, x, y, and number 2. So for the equations number 2, I'm going to multiply it by each of the term by 2xy. All right, so for the first one here, the x and the x will be cancelled, and here the y and the y will be cancelled, and this number 2 and number 2 will be cancelled. All right, so therefore here you're going to have 2y plus 2 times 2x, which is 4x, equal to xy. All right, so this will be my equations number 4. All right, next I'm going to substitute the equations number 3 into the equations number 4. So 2y bracket, I'm going to substitute it with negative 2 minus 2x plus 4x equal to x bracket negative 2 minus 2x. So next we're going to expand for this part. All right, so if you notice here, negative 4x plus 4x, it will be equal to 0. So we will cancel it. So this is a quadratic equation. So I'm going to move these two terms to the left hand side. So I'm going to write it in general forms. So here you're going to have 2x squared plus 2x minus 4 equal to 0. So here we can simplify it by dividing every terms by number 2. So here you're going to have x squared plus x minus 2 equal to 0. So to solve these quadratic equations, we can use the factorizations method, as this one can be factorized completely. So here the first bracket is x plus 2. The second one is x minus 1 equal to 0. Therefore, x is equal to negative 2, or the other one is x equal to 1. So x equal to negative 2 is already the solutions that is given in the question itself, where the coordinate is negative 2 and 2. So now to find another solutions, so we're just going to look at when another solutions. So when x is equal to 1. So when x is equal to 1, so we're going to substitute this into the equations number 3. So therefore the y is equal to negative 2 minus 2 brackets. We're going to put in the number 1. So therefore the y is equal to negative 4. So the other solutions for this question is when the x is equal to 1, the y is equal to negative 4. So you can write this in coordinates form. Questions number 4. The hypotenuse of a right angle triangle is 2x plus 3 centimeter. The length of two other sides are x centimeter and x plus y centimeter respectively. Given that the perimeter of the triangle is 30 centimeter, so find the value of x and y. Alright, so here I have a diagram of a right angle triangle. So here is stated that the hypotenuse is 2x plus 3. So this is our hypotenuse, so it's going to be 2x plus 3. So the other two sides will be x and x plus y. So I just going to label this as my x, and the other one is the x plus y. So here to find the x and y, we need to form the equations first. So the first one is based on the perimeter of the triangle, which is equal to 30 centimeters. So the perimeter, we just need to sum up all the length. Therefore, it's going to be 2x plus 3 plus x plus y. All right, this will give you the answer of 30. So we solve the last terms. 2x plus x is 4x plus y, and I got to move this positive 3 to the other side. So it will be 30 minus 3, which is equal to 27. So as the y, the coefficients of y is equal to 1. So I just want to let the y to become the subject of the formula. So y is equal to 27 minus 4x. All right, so this I'm going to label it as my equations number 1. Now for my equations number 2, as this is a right angle triangle, so we can use the Pythagoras theorem. So in Pythagoras theorem, it stated that a squared plus b squared equal to c squared. So the c here is the hypotenuse, the longest side in the right angle triangle. So the other two sides will be the a and b, right? So a squared plus b squared equal to c squared. So we're going to use this to form another equations. So the a is going to be x squared plus x plus y squared equal to 2x plus 3 squared. All right, so this will be my equations number 2. All right, so next I'm going to substitute the equations number 1 into the equations number 2. So x squared plus bracket x plus, so the y I'm going to replace it with 27 minus 4x, and then don't forget the square. As the other one, here we just need to expand this. So you're going to get, when 2x is squared, you're going to get 4x squared. So 2x times positive 3 is 6x, double it, then you're going to get 12x. Another one is 3 times 3 is equal to 9. All right, so for this part, we're going to solve for the like term, right? So here you're going to get 27. So x minus 4x is minus 3x here. So next we're going to expand for this part. So 27 squared is 729. So when 27 multiply this negative 3x, you're going to get, and then you double it, you're going to get negative 162x. And then negative 3x, when you square it, you're going to get a plus 9x squared. All right, so next I'm going to move everything to the left hand side. All right, so now we're going to solve for the like term. So first one is x squared plus this 9x squared minus this 4x squared. So here you're going to just get 6x squared. So next we're going to solve for the x. So negative 162x minus this 12x. So you're going to get negative 174x. And for the number 729 minus 9 is plus 720. All right, and for this quadratic equations, we are able to simplify it by dividing every terms using number 6. All right, so if not, you can use the calculator to help you to simplify this. So you're going to get x squared minus 29x plus 120 equal to 0. So we can solve this using factorization methods, and this one can be factorized completely. So the first bracket is x minus 24. The other one is x minus 5 equal to 0. Therefore, x is equal to positive 24, or the other one is x equal to positive 5. Now, to find the value of y, we are going to substitute x equal to 24 and x equal to 5 into the equations number 1. All right. So y is equal to 27 minus 4x. So the first one is 24, or the other one is x equal to 27 minus 4 times 5. So here the first one will give you the answer of negative 69. The other one will be 7. All right. So here we have two pairs of answer. So the first pair of answer is when the x is equal to 24, the y is equal to negative 9. And the other one is when x is equal to 5, the y is equal to 7. Now, if we look at the one that we label as the b, which is the x plus y, right? So if you substitute the x 24 and the y with negative 69, what happens is that this length here will be in negative form, right? So we don't have the length in negative form. Therefore, for the first pair of answer here, we are going to reject this answer. All right. So the correct answer for this question number 4 should be the value of x is equal to 5 and y is equal to 7. So this is the answer that we're going to accept. Question number 5. Given that the total surface area of a cuboid with a square base is 66 centimeter square and the total length of the sides is 40 centimeter. So find the possible volume of the cuboid. So this is the diagram of the cuboid with a square base. So as the base is in the form of square, therefore we can label it using the same letter. So for example, x and x here. And the height of the cuboid here, we can label it using another variable, for example, using y. Alright, to find the volume here, so we need to find what is the value of the x and the y. So first we need to form the equation first. So here, given that the total surface area of the cuboid is 66 centimeters square. Now, as the surface of the bottom and the top is in the form of square, therefore the area is x times x, which is x squared, and you have 2 of it. Therefore, you're going to have 2x squared. All right. And for the rectangular area is x multiplied by y, and you have 4 of it. Therefore, it's going to be 4xy. So when we sum up the total surface area, it is equal to 66. So here I can simplify it by dividing every term with number 2. Therefore, x squared plus 2xy equal to 33. Alright, so this will be our first equations. And the second equations will be the total length of the side is 40 centimeter. Now, as the bottom and the top is in the form of square, therefore the total length for the bottom will be x plus x plus x plus x, which is 4x, and top of it is another 4x. So therefore, from there you're going to have at x. And for the height, which is in the form which we label it as y, and you have 4 of it, therefore it's going to be 4y. So we sum up all of these sides, it will give you the answer of 40. Alright, so these equations we are able to simplify it as well by dividing every term using number 4. Therefore here you're going to have 2x plus y equal to 10. And as the coefficients of y is equal to 1, therefore I'm going to choose the y here to become the subject of the formula. So y is equal to 10 minus 2x. Alright, so this I'm going to label it as my equations number 2. So now we're going to solve these simultaneous equations So we're going to substitute the equations 2 into 1. So x squared plus 2x, so the y is 10 minus 2x equal to 33. So next, expand this. So here you're going to have 20x minus 4x squared, and I'm going to move this 33 to the left hand side so that the right hand side will equal to 0. So now we're going to solve for the like term and arrange this in the general form for the quadratic equation. So when x squared minus 4x squared, you're going to have negative 3x squared. All right, plus with the 20x minus the 33 is equal to 30. So as the coefficients of the x squared is in the form of negative, right? So in order for you to able to factorize it easier, so we're going to change it to positive. So I'm going to divide every terms with negative 1. Therefore, here you're going to have 3x squared minus 20x plus 33 equal to 0. So we can solve this using the factorizations method, as you are able to factorize this completely. So the first bracket you're going to have is 3x minus 11. Another one is x minus 3 equal to 0. Therefore, the value of x is equal to 11 over 3, or the other one is x equal to 3. All right, so now we're going to find the value of y. So here I'm going to substitute the value of x that we find into the equations number 3 to find the value of y. So the first one is going to be y equal to 10 minus 2 times 11 over 3. Or the other one will be y equal to 10 minus 2 times 3. So this one, after you solve it, you're going to get the answer of 8 over 3. And the other one will be 10 minus 6, which is equal to 4. So here we have two pairs of answer. One of it is when x is equal to 11 over 3, then the y will equal to 8 over 3. And another pair of answer is when x is equal to 3, y is equal to 4. So now we want to find the possible volume of the cuboid. So now to find the volume of the cuboid, we're going to multiply the length with the width and the height. Therefore, it's going to be x times x, which is x squared, multiply the y. So x squared y. So now we're going to substitute first using the first pair of answer here. So the volume, so the x is 11 over 3 square multiply the y, which is 8 over 3, or the other possible value of the volume of the cuboid will be, we're going to use this x equal to 3, so it's going to be 3 square multiply with the 4. So solve this using your calculator. The first one you're going to get 35.85 centimeters square, or the other one will be 3 square, which is equal to 9, multiplied by 4 equal to 36 centimeters square. So this is the two possible volume of the cuboid. Questions number 6. A fish is moving in a circular manner with the equations of its locus being 2x squared plus 11y squared plus 2x plus 2y equal to 0. A boat is moving along a straight line of equations x minus 3y plus 1 equal to 0, and it intersects with the circular locus of the fish. So find the points of intersections between the locus of the fish and the trajectory of the boat. All right, so I have a diagram here. So the circle here is representing the circular locus of the fish. And then this straight lines is the trajectory of the boat. So if we draw this circle and these straight lines of these two equations on the Charterson planes, so what we want to do is we want to find the intersection points between this the locus of the fish and the trajectory of the boat. So here we need to solve these simultaneous equations. So first, the equations of the circular locus of the fish, we're going to let it to become our first equations. And for the boats, the equation is x minus 3y plus 1 equal to 0. I'm going to label number 2 for this equation. And we're going to solve this using the substitutions method. So I'm going to choose the x from the equations number 2 to become the subject of the formula. So from 2, x is equal to 3y minus 1. Alright, so this will be our equations number 3. So now I'm going to substitute the equations 3 into the equations 1. Alright, so 2 brackets 3y minus 1 square plus 2 brackets another x there. Alright, so now we're going to expand for these two. So 3y, when we square it, you're going to have 9y square. So when 3y multiply this negative 1 is negative 3y, double it, negative 6y, negative 1 square it, plus 1. Alright. And for this one, you're going to have 6y minus 2 plus 2y equal to 0. So next, we're going to expand for this part. So 18y squared minus 12y plus 2. Alright, as for this positive 6y and plus 2y here, so sum it up together, you're going to get 8y and then minus 2 equal to 0. So now we're going to continue to solve for the like terms. So 18y squared plus this 11y squared, you're going to get 29y squared and negative 12y plus 8y. So this will give you the answer of negative 4y. So this positive 2 minus this 2 will equal to 0. So it will be cancelled. So next we're going to solve this using the factorizations method. So we have a common factor here, which is the y. So I'm going to write it at the front and put in a bracket 29y minus 4 equal to 0. Alright, so the first answer is y equal to 0 or 29y minus 4 equal to 0. So we're going to continue for the second part here. Therefore, the y here is equal to 4 over 29. So now we want to find the x. So here we're going to substitute the y that we find into the equations number 3. So the first one will be x equal to 3 times 0 minus 1, or the other one is x equal to 3 times 4 over 29 minus 1. So here it's going to be 0 minus 1, negative 1. And here will be 12 over 29 minus 1, which is equal to negative 17 over 29. So the question is find the point of intersections. So which is the coordinates. So the first point of intersection will be when the x is equal to negative 1, the y is equal to 0. And the other point of intersection is when x is equal to negative 17 over 29, the y is equal to 4 over 29. Question number 7. A sailing boat is moving in a circular manner with the equations of its locus being 2x squared plus 4y squared plus 3x minus 5y equal to 25. Meanwhile, a speedboat is moving along a straight line of equations y minus x plus 1 equal to 0, and it intersects with the locus of the sailing boat. So find the points of intersections between the trajectories of the sailing boat and the speedboat. So this question is more or less the same as the questions number 6. So we want to find the intersection point between the locus of the sailing boat and the trajectory of the speedboat. It means find the coordinate. So we're going to solve these simultaneous equations. So this one I'm going to label it as my equations number 1. And this is going to be my equations number 2. So here I'm going to choose the y from the equations number 2 to become the subject of the formula. Therefore, from equations number 2, y is equal to x minus 1. So this is the equations number 3. So next, I'm going to substitute the equations number 3 into the equations number 1. So the y, we're going to replace it with x minus 1. Alright, so next, let us expand for these two parts. So put a bracket here. So here, if you expand it, you're going to have x squared and then negative x, double it, negative 2x plus 1. And as for this part, you're going to have negative 5x plus 5. And I'm going to move this 25 to the left hand side. Alright, now we continue to expand for this part. Alright, and for the like terms here, the positive 3x minus the 5x, this will give you the answer of negative 2x, and 5 minus 25 is negative 20, so equal to 0. So we will continue to solve for the like terms. So 2x squared plus the 4x squared here is 6x squared. Negative at x minus 2x is negative 10x, and positive 4 minus 20, negative 16. So this equal to 0. Alright, so we can simplify these quadratic equations by dividing every terms using number 2. So next here you're going to have 3x squared minus 5x minus 8 equal to 0. So we can solve these quadratic equations by using the factorizations method. So the first bracket you're going to have is 3x minus 8 followed by x plus 1. Alright, so therefore x is equal to 8 over 3, or x is equal to negative 1. Alright, so now we're going to find the value of y. So here, okay, I'm just going to write here. So I'm going to substitute the value of x that we find into the equations number 3. So the first one is y equal to 8 over 3 minus 1, or the other one is y equal to negative 1 minus 1. So for the first one here, the answer is going to be 5 over 3, or the other one is y equal to negative 2. Alright, so the point of intersection, so here is referring to the coordinate. So the first one is when the x is equal to 8 over 3, the y is equal to 5 over 3. And another point of intersection will be when the x is equal to -1, the y will equal to -2.